All right, so section 3.4 is one of the few sections that I haven't done anything to. I think I initially wrote my college algebra material in 2009-ish, and then now we're living in the world of COVID. It's going to be 2021 here in a second, and pretty soon that's going to date this video. And anyways, I finally have time to update my material and update the videos. The videos, my old videos were just like 4 or 5 years old, but I wanted to update the material, and this section felt good enough. And it's important again. It's just function notation for me isn't never was my friend, and so it's just more function notation. A lot of it's just kind of plug and play and see what we get. But there's some stuff at the very end of this section that you can't skip because it comes on the test. So watch it all the way through to the end. There's definitely there's chunks of problems in this section. This is probably going to be a 3-part video, especially I just wasted 1 minute. So each of the problems between 1 and 18 start off and they call out one of 4 given functions. Problem 2 calls out the function f of x, which is given as 3x plus 4. And it asks me to evaluate it at f equal to -2. Doesn't mean to multiply by -2. In function notation, if there's a number in a parentheses, it means to take the number in the function and change it to that value. So I'm going to change the x to -2 and just do orders of operations. Do the multiplication followed by the addition. For an answer for problem 2, it's weird that it comes out to be the same value as the x. I can just write -2, or I could say the function value that I get when I evaluate at x equal -2 is y equal -2. When you plug a value in for x, you get a y. Both answers are fine. Problem 4 calls out the g function. And the g function for this set of 18 problems is g of x is x squared plus 5x plus 6. And it wants me to find g of 0, which is going to be 0 squared plus 5 times 0 plus 6. I'm going to be lazy and skip some steps here. 0 squared is 0. 5 times 0 is 0. 6 is just 6. This comes out to 6. If I was doing proper orders of operations, I might have put an extra line of work in. For an answer to number 4, it's either just going to be the number 6, or I could write g of 0 equals 6. Both equally correct answers. Problem 5 and 6 call out the h function. I've been helping my nephew with Math 151 at GCC this semester, and he's not liking these constant functions. H is called a constant function. When I look at h, there is no x. If this bugs you, you can rewrite it. This function would be the same as h of x equals 0x plus 4. This reduces to 4 because 0x is just 0. Anything times 0 is 0. So these two functions mean h of x equals to 4. If I wrote the function like this, then it would be easy. You would say h of 3 equals 0 times 3 plus 4, which is going to be 0 plus 4, which is going to be 4. When a function doesn't have an x, it's called a constant function. And constant functions are called constant functions because regardless of the value that you plug in for x, you're going to constantly or consistently always get the same number. My answer to 6 could either just be the number 4, or I could write h of 3. I could actually do that, right? I can write h of 3 equals to 4. Using the problem with the answer is preferred, but it's not necessary. 8 is calling out the k function. The k function for this set of 18 problems is written as 2 over x plus 3. I'm asked to find k of -6, so I'm going to change the x to -6. Usually when I'm replacing a variable, I use a parentheses, but I don't when it's a naked letter. When the letter doesn't have an exponent or a coefficient, when I substitute, I usually just put the number in without a parentheses. Let me simplify the denominator. Negative 6 plus 3 is negative 3. This is a correct numerical answer for problem 8. That honestly looks weird. I should know that I'm allowed to either move the negative up to the numerator or drag the negative out front and make it a coefficient. All three of these would be correct answers without the function notation, and I could write a correct answer with function notation. Kind of what I generally write is putting the negative in the numerator. It's where I'm most comfortable putting it. It doesn't, sometimes gets lost if you sneak it out front. Problem 10 wants me to use the f function and change the x to c. Not going to be able to simplify that much. So f of c is going to be 3 parentheses c plus 4. And when I have a number here, like if I was plugging in 2, if I didn't put a parentheses, it would look like 32 plus 4. Like if I was finding f of 2 and I wrote 3, 2 plus 4, looks like it should be 36 as opposed to what it's supposed to be equal to. With letters, the parentheses aren't quite so important. The parentheses means times, and writing the problem without the parentheses is probably a better way to write it, because this still means 3 times c plus 4. This I shouldn't set equal to 0. So many students that are struggling with this material feel like there's more to do, and they take that problem and set it equal to 0 and write negative 4/3 for an answer. Then I have to take off points because that's not asked for. The only time I'd set a function equal to 0 is if there was something in the instructions that said, you know, find f of x equal to 0 or find an x-intercept. But if I'm just evaluating a function, I evaluate and I stop. 12 wants me to find f of b minus 2, so I'm going to change that x to a b minus 2 and get 3 times b minus 2 plus 4. Clear the parentheses that I put in and get 3b minus 6 plus 4. And then combine the negative 6 and 4. Now I'm going to write the lazy answer. I'm going to write the answer without the function notation. Completely fine to do that. My answer could be 3b minus 2. One of my most bizarre stories from teaching at GCC since '94, like in about 1997, this is before I got married, then I got divorced, unfortunately. Anyways, I have this habit of writing 2's like this and like this. And a student in the 90s, when I was, still young, just barely 30, came up to me after class one day and she said, "You can't commit to how you write your 2's. How can you possibly commit to somebody?" And I guess maybe there's, some truth, unfortunately. But anyways, never ever will forget that story. I kind of forgot the name of the girl that told me this, but the story I'll never forget. It's fantastic. 14 calls out the g function, wants me to find g of 3a. The g function is x squared plus 5x plus 6. I'm going to change each of the x's to 3a. This is going to factor. I'm not going to factor this. Let me just simplify the best I can. 3a squared is 3a times 3a, which is 9a squared. Oh, maybe I will factor a little bit. 5 times 3a is plus 15a, plus 6 is plus 6. I'd live with this for an answer. This I'd give you full credit on a test. A better answer would be to pull out a common factor of 3 and write 3 times 3a squared plus 5a plus 2. And an absolute best answer would be to go 3 times 3a plus 2 times a plus 1. Any one of these is fine. If you're an awesome factorer, factoring is fantastic. Notice I factor in my head. I didn't use any grouping bottoms up method or anything fancy. But for these evaluating functions, if you just get the function, I'm okay with that. We don't need to go about simplifying. But it's always nice if there's a common factor. You should automatically, if you see a common factor, try to factor it. And if you see a trinomial and you're quick at factoring it would be nice. For 16, g of x plus 1 is going to be a mess. I'm going to change this x squared to an x plus 1 squared. I'm going to change this plus 5 times x to 5 times x plus 1. And I'm going to change this 6 to plus 6. X plus 1 squared, I have to do foiling to simplify that. X plus 1 squared is x plus 1 times x plus 1. The foiling part of this is firsts are x times x, which is x squared. Outers are x times 1, which is plus 1x. Inners are 1 times x, which is plus 1x. Lasts are 1 times 1, which is plus 1. So many, even good students, would have thought this is just x squared plus 1. Super common mistake. When you see an exponent outside of parentheses that has a binomial, you have to change it and FOIL it. Continuing in my simplifying, I'm going to go plus 5 times x, plus 5 times 1, plus 6. Now I'm going to combine like terms. That's 1x plus 1x plus 5x, which will combine to a 7x, and then 1 plus 5 plus 6 combined to a plus 12. And the x squared is going to lead off my answer, but not combine. Better to factor this if you can. When we're just evaluating functions, if this was a test question, I would write the factoring down for you, but I won't take points off. Both of those are good answers. Neither one of them have the function next to it. I just write the right-hand side, and that's okay. (17) and 18 call it the k function. K function is 2 over x plus 3. Because the x is just a naked x, I don't need to use parentheses when I change the x to an a minus 2 for problem 18. So this is going to be 2 over a minus 2 plus 3, which is going to be 2 over a plus 1. This fraction can't be reduced. A fraction with an a plus 1 in the denominator could only cancel or reduce if the numerator was factored and one of the factors was a plus 1. The answer to 18 is just going to be 2 over a plus 1. The next few problems, again, look like they want me to do multiplication, but they don't. They just ask me to find each function. And inside of parentheses, to the left of the x, there is an operation that is between the two function names. Problem 20 wants me to subtract the right side of the g function minus the right side of the f function and leave the variable x. This parentheses x doesn't mean to multiply by x, just says don't change the x to a number. It's the left side here that I'm really worried about. I'm supposed to subtract the g function first minus the f function. The g function is 2x squared plus 5x plus 3. It's written first. I'm going to write it first. The minus sign is written second in the first parentheses. I'm going to put it second. And then the f is written second or third. I'm going to write it last. This is what g minus f of x is. I just need to simplify this. First parentheses that I put in really isn't necessary because it doesn't have an exponent or coefficient. So I'm just going to drop the first parentheses. The second parentheses is necessary. I'm going to clear the parentheses by changing the sign of the positive 2x to negative 2x by changing the sign of the positive 3 to the negative 3. Now I'm going to combine like terms. The like terms are the 5x minus 2x and the plus 3 minus 3. I'm going to bring down the 2x squared, and then 5x minus 2x is positive 3x, and the 3's cancel. This would be a nice answer for problem 20 if I just want to write the right side of my answer without the original problem, which is what I guess I generally do. And that does factor. There's a common factor of an x. It's never wrong to factor. It's generally preferred. But when we're just finding functions, if you get me the right function, I'll live with it. For problem 19, you're going to put the f function in a parentheses first because it's mentioned first. A plus sign because that's the sign that I see in that parentheses. And you're going to have a second parentheses with the g function in it. Both your parentheses can be dropped without any changing because there isn't a minus sign in front of a parentheses, there isn't a coefficient, there isn't anything that would cause me to change signs, and then you'll just combine like terms. Maybe it factors a bit if it does, factor it. If it doesn't, don't factor it. But if you don't catch the factoring, even if it does factor, I'm not going to ding you. 21 asks me to divide, 22 asks me to multiply, 23 asks me to divide. So in 22, I'm asked to multiply the g function times the f function. This little times sign doesn't really need to be shown. Like I needed the plus sign between the parentheses because it's never implied. I needed the minus sign between the parentheses. It's never implied. Somehow I think this is not a bad answer. But I'm going to multiply this out anyways, just so I can show you how this multiplies. And I'm kind of regretting this right now, but let's do it. To multiply this, first I'm going to multiply 2x times 2x squared. I multiply the 2's and get 4. And x times x squared, I add the exponent of 1 and 2 and get an x cubed. If I wanted a factored answer, I wouldn't multiply this out. The fact that I'm multiplying it out means I'm not giving a factored answer because it's already factored. Second multiplication, 2x times 5x. I multiply the 2 and 5 and get positive 10. I multiply x times x and get x squared. Third multiplication, 2x times 3. I multiply the 2 and 3 and get positive 6. I leave the x. Fourth multiplication, 3 times 2x squared. I get 3 times 2 is positive 6. And I get an x squared, and watch what I do. Instead of writing it vertically after the 6x, I wrote it under the 10x squared to help my simplifying. Next multiplication, 3 times 5x is positive 15x. Last multiplication, 3 times 3 is 9. This whole multiplication will simplify to 4x cubed plus 16x squared plus 21x plus 9. Our two division problems, which are both yours, division problems, that little slash means division, and I'm going to form division problems with a fraction bar. The fraction bar kind of works as a parentheses. It makes the parentheses not necessary. And for problem 21, f divided by g of x would be a fraction with f in the numerator and g in the denominator. I'd live with this. I would love it if you could do this. This is an intermediate algebra, section 1.4, part 1. But for now, I won't put anything like this on a test that has such ugly factoring and simplifying. You should, everybody in this class should be able to factor that given enough time. Not as fast as I factored it, but that's actually how that factors. I could cancel this, and this is a, mediocre answer that I'd give you full credit on a test. On our tests, the dividing problem doesn't factor and cancel like this. This is actually the best answer. If you're going up the calculus sequence, way high, Calc 1, Calc 2, Calc 3, maybe beyond that, your factoring skills need to be just fantastic. Your algebra skills need to be fantastic. If brief calculus is even in your future, your algebra skills need to be pretty good. Not as good as a traditional calculus class. 20 minutes, I can do another 10. we have, for the next few problems, a new operation that looks like multiplication but isn't multiplication. Problem 24 and 25 have this open circle, and this is another thing that I sneak on tests. This open circle means composition. It means to replace any x in the first function that's mentioned and in problem 24 that's f, in problem 25 that's g, with the right side of the second function that's mentioned. This is not pleasant at all. Get ugly algebra usually, and let's just go through it. So sometimes teachers will be nice and books will be nice, and they will use this in place of composition. Say evaluate f, replacing the x with the g of x. This tells somebody that reads function notation awesomely is that I'm supposed to take the f function and change each x to the entire g of x function. Let me show you 24. So f, I read this as composed with g of x. The x in the parentheses doesn't mean to multiply by x, just means leave the x alone, don't change it to a number. What I'm going to do is I'm going to take the f function and change the x to the right side of the g function, which is going to be 2x squared plus 5x plus 3. And let me simplify this. This is going to be 4x squared plus 10x plus 6 by multiplying through by 2 plus 3. My answer for 24 is going to be 4x squared plus 10x plus 9. That's actually prime. Let's do 25 together. I'm going to skip on maybe 26. 25, the function that's written first is the g function. What I'm supposed to do when I find g composed with f of x, I'm going to take any x in the first function that's mentioned and replace it with the second function that's mentioned. So in this case, the first function that's mentioned is g. On the right side, it has two x's. I'm going to replace both x's in the first function that's mentioned, g, with the right side of the second function that's mentioned, f. Both x's need to be replaced. This is disgusting, but let me get through this. For the simplifying, this 2x plus 3 quantity squared is 2x plus 3 times 2x plus 3. I have to FOIL that. And when I FOIL that, I still have to multiply by 2. First are 2x times 2x, which is 4x squared. Outers are 2x times 3, which is plus 6x. Inners are 3 times 2x, which is plus 6x. Last are 3 times 3, which is plus 9. So when you're simplifying, orders of operations ask you to do the exponents first, and that's more or less what I've done, other than I haven't combined the like terms inside the parentheses. So I've done the exponents, and I've simplified the first parentheses because it can be simplified. The important thing is understanding that this open circle doesn't mean multiplication. The x in the parentheses doesn't mean to multiply by x. There's two really super common mistakes. Let me simplify this to be 8x squared plus 24x plus 18 by multiplying through the first parentheses by 2 plus 10x plus 15, multiplying the second parentheses by 5 plus 3. My like terms are 24x plus 10x and 18 plus 15 plus 3. I'm going to bring down my 8x squared. 24x plus 10x is 34x, and 18 plus 15 plus 3 is 36. This is the best worst answer. It's good enough. Factoring out a common factor of a 2 is always better. Common factor factoring should be easy for everybody. I probably could factor that too. Or maybe I can. Let me see. There's a way to use the quadratic formula to factor. And I'm doing that off screen. If this was an in-person class, I would teach you how to do this. This guy factors into x plus 2 times 4x plus 9. I wrote a program that does the quadratic formula. I entered the coefficients of 4, 17, and 18 in my quadratic formula. The quadratic formula spits back numbers, and I could change those numbers into factors. If this is an in-person class, I'll absolutely show you how to do it. If not, you might do a Zoom meeting with me, and I can teach you how to factor with the quadratic formula, which is kind of slick. I actually wrote a program that I could usually give you if we're not in the world of COVID to do the quadratic formula. But this is fine. If you just stopped right there, I'd completely live with that for an answer. Let's do a few more of these. Let's do 29 together. Subtractions are harder. To do 29, I want to do g minus f of x. I have new functions, it looks like. The g function now is turned to x minus 3. The f function is 2x squared minus 5x minus 3. So I wrote the g first, the minus sign from the problem second, the f second, put each in a parentheses. The first parentheses I can just drop. I'm going to emphasize that that x has an implied coefficient of 1. Second parentheses, attach the negative to the 2x squared. Change the sign of the negative 5x to positive 5x. Change the sign of the negative 3 to positive 3. This I'm going to write first because it has the highest exponent. I'm going to combine 1x plus 5x and get plus 6x. And how nice, the 3's cancel. These negative 3 and positive 3 are opposites, they cancel. Can live with this for an answer, but this only has common factor factoring. Should always try to do common factor factoring. My common factor is a negative 2x. Factor out a negative because the first term is negative. Factor out an x because both terms have an x. Can't do common factor factoring. That's my intermediate algebra section 1.1. It's about a half-hour video, and you should be able to learn real quickly. Maybe it's longer, but in a half hour you can learn quickly how to factor this. That would be a best answer. 31, that's not composition, that's times. That solid circle is times. So if I wanted to do 31, I'd write the g function first. I'd write the f function second, and then I'd do all the multiplications and combine like terms. If I wanted a factored answer, I wouldn't take the time to multiply it out. I'd leave it factored. Let me get 32 started. 32 wants me to form a fraction with g in the numerator, which is x minus 3 in the numerator, f in the denominator. I can live with this for an answer. Hopefully your factoring skills are good enough that if I gave you enough time that you could factor this denominator into 2x plus 1 times x minus 3 so that this fraction can reduce to 1 over 2x plus 1. If we're in an online world and you're cruddy at this kind of factoring, this is Intermediate Algebra Section 1.4. Watch the first half hour of that video, and that will teach you how to factor these by hand, not factor in your head like I just did. or not factor using the quadratic formula, which is another trick I like to teach in in-person classes. But good skill to have to be able to factor. But I would live with this for an answer, and I can't recall anything on the test with a fraction that factors and cancels. Let's do like one more problem and then move on to a part 2 for this video. One more composition. I'm going to do problem 34 to find g composed with f of x. So I'm going to write the g function without the x. I'm going to replace the x in the g function with the entire f function, which is 2x squared minus 5x minus 3. So I'm replacing this x with the f function because the g is written first. I'm replacing the x's in the g function with the f function. This is baby food. That parentheses doesn't have an exponent. It doesn't have a coefficient. It can just be dropped. And now I'm going to combine like terms. That is prime. Your problem 33, much uglier because the f function is written first and I have composition. I'm supposed to take each x in the f function, the function that's mentioned first, and replace it with the second function. Your problem 33 should be 2 times x minus 3 squared minus 5 times x minus 3 minus 3. We're at 31 minutes. Let me just get this started for you. X minus 3 squared technically needs foiling. If you teach this class for 30 years, you know how to FOIL that in your head. That comes out to x squared minus 6x plus 9. So that would be the start of 33. I've got, I did the substituting. I changed both x's in the f function because it was written first with the function that's written second, which is x minus 3. Started the simplifying. You can finish the simplifying. We're at 32 minutes, so we're going to move on to a part 2 to this video.